Okay, so this is a very brief presentation regarding IPOL, what is IPOL, what are the MLBriefs, and so I will give a short overview, and then I will point you at some guidelines regarding the writing of the articles and the software, and some requirements for the authors, and then I will briefly describe also the typical structure of the manuscript, the demo, and I will say a few words about the source code. And then I will show some different kinds of articles so that you can have an idea of how broad it is, the types of contributions that you may make. So what is IPOL? IPOL stands for Image Processing Online. It's a fully reproducible research journal that was founded in 2011. It's also peer-reviewed and it's completely open access. Originally, the topics were centered around the general image processing, also computer vision, and then we got broader in the kind of signal and in the kind of methods. So we started accepting works on signal processing, time series, remote sensing. Start my Safari, sorry. So, yeah, so as I was saying, we extended the areas of applications and the kind of methods we manage. Typically, we didn't used to include methods that use networks because of the time of training, but then we decided that we would accept them and be able to upload the models and the weights and just doing the inference and this kind of modifications that came with time. What makes different, in particular, IPOL from other publications is the fact that it's a bundle of different things. You have on one side you have an article that describes an existing method or a method you propose. It also has an open source code implementing this method. Finally, it has a demo that runs on IPOL servers, and it's supposed to run exactly the same code that you upload, that other people should download. So this is a very practical way to test an algorithm before you decide to do something with it. Aside to the demo, you have every demo has an archive that registers the experiments, and the user typically has the right to accept or to decline his experiment to be recorded. It's very practical, let's say, in a situation when somebody runs the demo with a given, with his images and it crashes or something else. Okay, you have a way to, or gives, but not typically crashes, but the results are unexpected, so you have a way to recreate this situation in order to debug. So typically, this is what you see when you click on an IPOL article. You have the article per se. And here you have a small abstract, and then you have a low resolution version of the article. You typically also have the full resolution. And here you have the source code. You go to here, we were in article, when you go to demo, this is a typical demo. You see some images that are preloaded by the author, but typically you can upload your own data. It has a short description, and then well, the gallery of images that were already uploaded, and a set of parameters with their own description. And then you have the archive, where you can see the experiments that were performed by people that allowed their experiments to be recorded. So you just click here on reconstruct, and then it repeats the experiment with the parameters that were used. There are plenty of guidelines in the website of IPOL, so I won't go into the details, but you have an author manual which gives you an explanation of everything, and mainly has links to other documents, but it has a short explanation of how the article should be written, how the software should be prepared and uploaded, and different guidelines. Then you have there, if you go there, it will point you to some manuscript guidelines, which is something more related to what I will talk now, which is how to write an IPOL paper. And then you have some software guidelines. There's an important requirement because it often happens to us that the articles that we receive are too far to the result they should have, to the level they should have to get published. So we will allow ourselves, or typically that's something we should always do. I mean, we can do, but we never do it, which is the possibility to reject papers. Lately, we are receiving a lot of papers only by students, and typically it would be good if there's like a more experienced research. It can be either on the list of authors, or if not, it would be good if somebody helps the students in order to have a result which is closer to publication, because otherwise the reviewers or the editors end up doing a lot of work, and in fact they transform themselves like kind of authors, so it shouldn't be that way. Our goal is to help you to publish the paper, but our goal is not to write the paper for you. So about the manuscript. There's an important difference, mainly with what you see typically on journals now, or in conference, maybe on conference, that people are eager to sell their method and just show the advantages, and sometimes this is done in a clean way, and sometimes not. Here you don't have to go through that. You don't need to sell the method. You only need to describe it. And in many cases, you won't be even implementing or describing your method. IPOL allows you to write an article on somebody else's method. So there's no point here in trying to sell a method. We really need to be objective and fair. But what we look for is an in-depth description, not only on the theory, but mainly on the and that's the difference, mainly on the practical aspects, which should give a detail that is that allows a reader with some experience to reproduce the method by reading the article. This is more the case for IPOL. For the MLBriefs, it's a little bit different. We don't require that. Of course, the manuscript should be as comprehensive as possible. So everything which has to do with things that are considered as details in another kind of journal, here are not details. I mean, you really have to explain them. It's the way that somebody can reproduce the work. So typical things are how you manage initializations, what are the side effects, what kind of normalization you use, how you treat the hyperparameters, how you fix them, etc. These things, usually when you publish in a conference or in a journal, the standard way is to omit these details, because especially in conference now, conference they can be between 6 and 10 pages, so there's no room enough to explain all these details. But here we are interested in these details. The other thing that you should bear in mind is to try to reduce the choices for the reader and user. The idea here is not to discuss everything, is to state, to be close to the code and explain what the code does. And also, I will go to the experiments later. So, typical structure, you have an introduction as always. This introduction should be, I say should be because things are not written in stone. It may be that you require more room for the introduction, or the introduction could be short or whatever, but typically it's about 1 page long. The idea is to describe the task you want to solve and the global position of your approach in the literature. As I said already, you don't need to state that your method is better or more advanced than other methods. And also you don't need to include hundreds of references to show that you really control the state of the art and all that. You have to limit yourself to the major references that are important for your paper. I don't know, but if you're familiar with the literature, typically when you read a paper now of let's say CDPR or MLBriefs or whatever, people are eager to show that they know the state of the art, and then they have packets of 5, 10 references in the same place or things like that. We don't do that here. Then we have the method section, when you describe all the steps, including all the pre-processing. Remember that all the details are important here, so you have to describe them precisely and objectively. You don't need to tell a story. You have to go straight. You have to go straight to the point. It's good to include. I mean, we don't have space constraints. We want to be synthetic, but we don't have constraints. So if you want to include flowcharts that will allow the reader to easily understand the method when you put the most important steps, or for example, a diagram of a neural network or whatever, these kind of things are welcome. The idea is that the reader is able to understand, so it helps. And of course, usually we implement methods, we have math behind, so there should be equations if they are needed. And the same for the pseudocode. And actually, in regular IPOL journals, pseudocode is mandatory because it's a way to understand the code that you are giving with the article, and it should be described. The pseudocode should use the same notation, the same variables that you can find in the code. Then another important block is of course the experiments, and these IPOL papers can be very experimental because one of the goals, for example, is to test the method to the limits and show examples where the method works and where it doesn't work. So it's very important to provide we should be very formal with the evaluation, provide the equations for the evaluation metrics. It is not required, as is the trend now, to compare your method with the latest method from the state of the art. I mean, the comparisons, you can make comparisons if it makes sense. Otherwise, you don't need to do them. Unless the article is a review of methods, that is something that we've seen typically in MLBriefs, and I will show an example. You do not need to run numerous simulations on large data sets. You have to choose the good examples, the positive and negative results, in order to illustrate the advantages and limitations of the method. Remember that it's very experimental. That's the idea why we built this journal, people to be able to test the methods without even downloading and installing the code, just using the demo. And the article should, the manuscript should reflect that. It should present an in-depth qualitative analysis of the results, and the good way to do that is doing it on the same images, at least on a good superposition of the images you include in the demo. So what they showed here. No? It's you, the author, that chooses what images you put here, you put good examples, and analyze in the article the results of these experiments that you perform on these images.
Thank you.
Voilà.
We'll try again with the people on Zoom. Is it better now?
Now it
More or less. Wait.
I need my computer. Because otherwise we have disabled stuff. Yes, and then a very important aspect of this section is the evaluation of the parameters. There are many methods that are described in the literature that fix some parameters, they don't explain how, and you never find an evaluation of the impact of these parameters. So this is something that you should typically do here. And then you should always include a section that explains the detail. Typically, you can do that at the end of the article, usually before the conclusion, but you can do it afterwards. It's not very important. It depends on you, what you want to do. But it's important to guide the reader on the use of the name. Ideally, when somebody goes to the IPOL website and is interested in an article, sometimes the first thing they do is to go to the demo and to test it, and then to see if it's useful for his purposes. So some minimal information should be there in the demo webpage, but still there should be a more in detail description in the article. And of course, this is particularly important if the demo contains some analysis, typically with graphics or whatever, plots, etc., that is not included if you're implementing the method of somebody else and you're performing an analysis of it. Maybe you are showing different results that are not in the paper and the kind of analysis you perform. So it's very important that you describe all that in detail. You can use screenshots to have the reader to use the demo. Remember that the demo should be pretty short. I will show you some examples. So there's not room for a lot of detail, but this detail you should give it here. You have also to remind what are the input, output parameters, and whatever that is involved in the demo. That you certainly explain that when you present the methods and the experiments and so on. But you have to assume that somebody will go and the first thing they will do is try the demo, and then maybe they download the paper if they find the demo is interesting. And there should be the detail for that person to understand totally the demo, especially the parameters. Finally, so typically we used to have images as data, but now we have more complex data that come from biomedical records or whatever. In that case, it's very important that you explain the structure of the data formatting and whatever. Remember that sometimes many times people will try to use these codes on their data, so you actually be clear on the formatting that the algorithm requires and the demo requires. So then I move to the demo. I'm not talking anymore about the article, I'm talking about the demo. The typical way we build a demo is that it's done by on our side by editors. They build the demo for the authors. Sometimes when the authors are experimental and familiar with IPOL, we ask themselves to do it, but this is not a requirement. What the authors are required to do is to give their source code with the compilation instructions, usually within the same zip. And some examples of the data I would like to try on, and a brief description of the demo. In the description of the demo should allow the user to run the code and to understand what the method does. It is not necessary that to explain how the method works. That's the role of the article. But it's important that somebody who doesn't want to read the paper at the beginning is capable of understanding what's the input, what's the output, and what the algorithm does. And you can do that just in a few lines. This is just a couple of paragraphs, and you're done. It's also important to include, let's say, one or two references, which are the main references of the work. If you are implementing somebody's work, of course you put the reference of this work there in the, I'm talking about the description of the demo. Of course in the article you put all the references you need. But you have to put one or, let's say, two, just a reduced number of references, so that is there.
Maybe on your second point, maybe you could add that the author should provide also the default values of the parameters and the
yes.
extreme values.
Yes, yeah, that's very important. I'm going to mention that afterwards. Yeah, there are some details in the demo that one is the one Pascal mentioned that I will mention that briefly. So this is how the demo section look like. The demo section, no, sorry, the demo web page looks like. And this is just to show you that the kind of description we expect from you. So, for example, here now, this demo illustrates the method proposed by one on forgery detection. What are the inputs? What are the outputs? Here, the goal is forgery detection, so it's pretty clear what the algorithm does. There could be maybe more detail if the method of forgery detection is focused on observing the noise or JPEG from compressions or whatever. It could have a little bit more detail, but not much. It should be really short. You have to remember that usually people, when they are looking at these things, they want to test easily and they don't want to read much. You need to capture their attention afterwards. If they like the demo, if they like the results, etc., then and if your explanation was good enough, then they will certainly go and download the paper and even the code. So here you see brief explanation, one reference because this work was a work that implemented somebody else's work, and these are the galleys that I used to test the method. Here you have another example. Again, it's the same. You see, it's more or less the same format. The method aims to colorize grayscale images with realistic and vivid colorization using generative priors. That's enough.
I would like to add, for a technical point of view, on how to write this description with a list. You can see slide 45 of the day 2 tutorial.
Now, yes, some details about the demo. Typically, we want the demo to run fast, and we want the execution not to take more than 30 seconds. If it does, you need to take some actions. For example, when you're working with images, typically you will crop the images before passing them to the algorithm, the input, just to process the image, or you zoom out if the size is larger than a certain amount. that makes the code run slow. So you have to do these kind of tricks. Avoid putting plenty of parameters. In the important parameters that it should be there, of course, but that's, you know that there are typically parameters that don't have much impact, and then you can fix them yourself and not give the user this possibility. I mean, you need to put as much parameters as you consider it's important, but try not to put anything. This is what Pascal mentioned. You have to give default values for the parameters. There's a way to, I don't know if Quentin already explained that to you, but you can fix default values for the parameters. And you can also, it's very important, you can also fix intervals for the values of the parameters. Typically, you have sliders that allow you to fix the value of the parameter, and you can fix that range. Very important that each parameter has a short description of what's the role of that parameter, what it does. And as I already said, it's, the description should be detailed enough for someone who wants to run the code without reading the article first. Before finishing your work, it's important that you test the demo intensively, and if possible, to ask friends and colleagues to try it. It happens many times that if everything works fine, and then 1 week later somebody uploads an image and the code crashes, and the demo crashes. So it's better if you test a lot so that these things do not happen. It happened to you, but not to a user. In some senses, an avoidable, it may happen, but you have to be careful about that. For example, when I have to test a demo before allowing the publication, typically the editors, once the paper is ready to go out, we have to take a look. And typically, what I do is to test the method and the limiting values of the parameters. Because sometimes they say, okay, you can put the noise to 0, but actually you have somewhere in the math you have 1 over the sigma square, and then it explodes. So, and sometimes you don't think about that. So it's important to test the demo at the boundaries of at the limit of the parameters that you allow. These are just tips. Obviously there are much more. That's just to get started. About the source code, I won't talk about that. But you have there's a link here that explains to you the kind of README you should put and the structure and everything. Of course, you can do that, but you can also learn by example, so you can download the codes from other articles in IPOL and try to see how they are written. As in any code, you should document the code as much as possible, and remember that here it's really important that the pseudocode and the code use the same notation, the same names for the variables, etc. Then to finish, I just want to give you some examples of different kinds of articles, and maybe there are more that we didn't think of. But a very popular kind of article is an analysis and an implementation of an existing method. There are plenty. If you go to the IPOL main web page and you click on articles, you will see all the articles from 2011 to now, and you can take a look at them, and you will see that many of them are implementations of other existing methods. It's not just the implementation. I mean, it has to have some added value. Typically, the added value comes from testing the method a lot and to do an in-depth analysis. So, for example, this is an analysis and implementation of the VM3D image denoising method, a very popular method in denoising. That it has some, it has more than 10 years, but it's a classic method, and many new denoising methods using networks use this method as a baseline for comparison. So this method was not proposed by Marc Legrand, but he wrote an IPOL article analyzing how the method works. As I said, many times these works are presented in conference that they don't have too much room to explain the method, so there's always like an opportunity to do like a dissection of the method and explain it in detail. So you have the article here with the source code. You have the demo. Here you see the parameters. So actually, we should reject this paper a posteriori because it doesn't have a description. I think we weren't that picky at that time. It doesn't have a description, but
there were 5 articles, so.
But you see, for example, here, all the parameters that are here have a short description. Another typical kind of article is an article that works as a companion paper of another paper that was already published by you in another journal. So typically, when you publish in a standard journal, you don't have the space, and people are not interested in looking at these details. These are the details that, unfortunately, you have IPOL to describe them. You can do a very good description of the implementation. Here I'm showing another very famous method for line detection. And so the method was published, I don't remember where, I think in IEEE, PAMI or PAMI. So all the details of the implementations are given here. You have the code. At that time, it was not that popular that the codes there was not GitHub. Maybe at that time there was GitHub, but a long time ago GitHub didn't exist, and it was not that common to publish the code. Today, it's like everybody knows that you should publish the code and you publish and put it on your GitHub, or even Hiding Face does that job too. But at that time, it wasn't that frequent, so. So we did that from the very beginning, and we're still doing it. So this is the source code of the method. You have the demo. In this case, there's no parameter. There are some parameters which are not crucial. This method claims to be parameterless, so this is the demo. It is what it's doing. There's no parameter here. And of course, you have the archive. This work has plenty of experiments, as you may see. Another kind of so this is very useful for if you have an